All right, so let's start off Unit 1, Lesson 1. What is a limit? So a limit is the intended height of a function. And this lesson or this unit should pretty much be where you guys tried to finish up the end of last year. So some of this, I'm hoping you're kind of ringing a bell a little bit, but we all finished up last year in a total different way. So I'm going to try and teach this as if you've never seen it before, because you never really officially got a full lesson on it, maybe just a video, and towards the end of the year again. A limit is the intended height of the function. Now that's sort of a weird phrase to say right there, an intended height. What do we mean by an intended height? The important thing about a limit is that it isn't actually concerned about the y value. It's about the y value it's approaching. So special notation comes up when you're being asked a limit question. So if you focus in over here, this is an example of a limit. And you see literally the words LIM, or the abbreviation for limit. And that's what's telling you that the problem is asking for a limit. And it's not just asking you what's the y value, it's asking you what's the limit. What are you approaching as you approach this x value, which comes up below it as x approaches 6. That tells us what value we're approaching. Then in here tells you which function we're looking at. It could use a function name, like this one is saying f of x, or it could actually put something in there. If it puts x squared in there, you can say that you're approaching that value. And then it's equal to a y value. So this is important, that your answer is always a y value. And it's the y value that the function is approaching. And we're going to see by the end of today's lesson, the y value doesn't always have to exist there, but it has to be what we're approaching. So let's start off with this graph that I gave you. F of x is a smiling parabola, x squared plus 6x minus 4. So that's a nice, smooth, continuous, smiling parabola. And if we look at the example that I have over here, the limit as x approaches 6. So the x-axis is our horizontal axis. So x equals 6 is here. So as we're approaching x equals 6, they mean from both sides. Picture the line of the function as a road. And as you're approaching x equals 6, from both sides, what is the intended height, or what is your intended destination as you approach 6 from both sides? And it looks like we're supposed to, and we do actually wind up with the y value of 4. And that's why this answer is here. We're approaching 6 from the left and the right. So it's that whole vertical line that we're approaching. And we actually get to the y value of 4. So there's no issues here because we can actually see the location. Now, the x values are the domain. So let's just kind of remind ourselves of some vocabulary. So in this white space in here, we're going to fill in the definition of, let's do domain. And that's the set of x values where f of x is defined. Set of x values where f of x is defined. And then the range is going to be your set of y values. Or in other words, the heights that you achieve. The range is the y values. These y values are going to be your solution. We say a limit approaches an x value, but the solution is a y value. A limit approaches an x value. The solution is a y value. A limit approaches an x value. The solution is a y value. Now, before when I was kind of pointing to the graph, I really took advantage of the fact that I was showing you that I was approaching from both sides, that I was coming in from this way and this way. Like I was driving to that location from two different sides of the value x equals 6. And that's true as long as I'm not told otherwise. Limits are two-sided unless otherwise specified. So how would I specify that it was coming in from another way? Well, I would use a little plus or a minus for from the left, from the right. So let's write out this notation. We're going to say if, and now we can practice writing our limit notation, the limit as x approaches a. And now here's where my new notation is going to come in. After you write down the limit as x approaches a, sort of like an exponent on the a, I want you to put a little plus sign. That little plus sign means from the right side. And then we would have to give it a function, so we're calling ours f of x. So this now is reading, sorry about the delay a little bit, guys. If the limit as x approaches a from the right of f of x is equal to the limit as x approaches a, and then we would put a little negative sign, sort of like an exponent on the a, as from the left of the function. If they're equal, if from the left is equal to from the right, let's say they both equal, in this example, it was the number 4, right? But I don't want to put number 4 in one of these notes kind of boxes because it doesn't always have to be 4. Let's call it L, that it would be the value of the limit. If that equals L, both of them are the same. Then we can say the limit as we approach a normally exists. And it's also that value L. In this example, it was the 4, but it could be any number. The limit has to be the same value from the left and from the right. So kind of think of it as if you could take your two hands and drive in from both sides, do you meet? Like if you could actually clap your hands together, you would meet at the y value, then that means the limit exists. You were able to come together and clap your hands. We're going to start to see some examples where you come in from both sides and you're not going to meet up. And this is when we're going to have an issue with our limit. Let's take a look, though. I'm using this expression intended height of the function. Let's take a look at an example where there might be an issue with the y value. So the second example I have here is g of x equals x squared minus 6x plus 8, and it's all over x minus 2. Now, I know not everybody has their calculator today, but what I'm going to do is I'm going to plug this into my calculator for you. Maybe I can even just do this into Desmos, and that'll be faster. Let's try it. So I don't have to switch screens. All right. Good stuff. What's my function? X squared minus 6x plus 8. All in parentheses because then it's divided by the entire expression x minus 2. Kind of just looks like a line, right? Y-intercept, there's the line in red there. Throughout this course, I'm going to use the phrase, you have to be smarter than your calculator. Take a look at the function. And what makes you smarter than the calculator on this? What kind of function is that? What really can't possibly happen? What do you think, Ty? It is linear. I like that. Look at the original format of it, though. Because I almost wouldn't have guessed linear unless I really thought about it to start. I see an x squared, that's parabola, wound up not being that. I'm dividing by x minus 2. You think of something?
Doesn't that mean that, like, you can't have an x value of 2?
Can't have an x value of 2. At 2, agreed? Clap for that one. It's not showing me that it's not defined there. If we had your graphing calculators out, I'd bring up a table of values. I'm not going to mess around with the Desmos table of values only just because I feel like I'm going to wind up probably sucking up too much time instead of making my point. But we know that you cannot have 0 in the denominator. So let me just go back to the notes. Let's draw a little sketch of what we saw. We would have to put a bullet hole. I almost went to write on the board. I forgot I'm writing on here. At 2. So we had this y-intercept. I didn't draw attention to it, but it was actually down here at -4. And then the slope went up 1 over 1, up 1 over 1. And really at 2, -2, we would have to draw an open dot to say that this function does not exist at x equals 2 because we can't have 0 in the denominator. Desmos, your graphing calculator, they know that that's happening, but they really can only show it in the table of values. They're not programmed in order to put the circle or the open dot on the graph that they give you. I'm going to just label my x and y axis just to make a nicer picture. With that said, we would be able to write out that f of 2, the function evaluated at 2, does not exist. That's for sure. F at 2 does not exist. Sorry, that's an E. It's just going to pop up any second now. Go ahead. Make it an E. Sorry, those of you at home, we have a delay on the board a little bit here. I don't know if yours there. Asking for a y value, though, is different than asking for a limit. How do I know the problem? I'm actually going to see the limit. What if I asked you instead of this, the limit as x approaches 2 from the right of, this is named g of x actually, not f of x. So from the right, I'm going to jump on the road from the right side. And as I'm approaching 2 from the right, I actually have an intended height of -2. That's where I'm trying to go. It really doesn't matter that it's an open dot. I'm intending to reach -2. That's my limit. And you know what? Same thing from the left. The limit as x approaches 2 from the left of g of x well, that's coming in from this side. I wonder if I tilt this a little bit. If you guys could see me pointing at home. Maybe a little bit. Coming in from the left, the road from the left, it's also approaching -2. Looks like that's where I'm supposed to wind up. I give the analogy, let's say you live over here, your friend lives over here, and you guys are going to meet at the diner at x equals 2. You both get there and you find out that the diner burned down, but you met. The limit exists. The diner isn't there, but you actually met in the parking lot. Oh my God, the diner burned down. The limit exists. You got to speak to your friend. It doesn't matter that you approach that empty parking lot. All that matters is that from the left and the right met. So with that said, I can say that the limit as x approaches 2 with no direction, just the plain old 2. The limit as x approaches 2 then is always implied from both directions. Without a specific direction, you always have to come in from both sides. So the limit still exists and is -2. This is what I mean that the limit is the intended height of the function. Remember, f at 2 doesn't exist. We talked about that in the beginning, but the limit exists because the roads from the left and the right meet. Questions? All right, so down at the bottom here, when then doesn't a limit exist? And I think that's on the top of our next page. When doesn't a limit exist? Yeah,
There's like a jump in the graph.
perfect. Jump in the graph. You might have even been thinking there's a break in the graph, so I'll put break in parentheses. Now, the reason why that's the case is if there's a jump, I'm all the way down here at the bottom of the screen, or a break in the graph, technically, it's because the left-hand limit is not equal to the right-hand limit. So I'm going to abbreviate left-hand limit as LHL, not equal to right-hand limit, RHL. My second little dot here is kind of off the screen, so I'm just going to write mine up here so those of you in class can see it. Besides there just being a jump, there might actually be a vertical asymptote there, a line that it could never cross. So a second place is if there's a vertical asymptote. Because the limit from the left and the right aren't going to match because they're going to be going to infinities, opposite infinities. And since infinity itself is not a y value, it's really just a concept. If it doesn't approach a y value, the limit doesn't exist. Let's look at a graph where we kind of have all these different things going on. Questions before we move on? Nice. Sorry about the spacing of the board, guys. I know it's hard to see when you're sitting over here. I think it'll be a fair thing if we kind of make sure that we continue to rotate who gets stuck in the front a little bit, and each kind of take our turn over here, just to make sure that one person isn't always struggling to see. All right, so here's an example. I give you a graph, and I'm going to ask you for a bunch of different things. All right, if the limit doesn't exist, explain why. So if we're writing does not exist, we have to say why here. All right, so first thing that you're going to look at is what are we approaching, right? If you're going to make plans with your friend to meet at the diner, the first question you might ask is which diner are we going to? You have to know your destination. So that's the x approaches. The limit as x approaches 0. And now this is just one-sided. It's got that little from the left. So the x equals 0 is here in the middle. Now, there are a couple of things that are to the left of 0. What you have to do is sort of jump on the road that's immediately to the left of 0. So as I approach 0 from the left, I'm really on, whoops, sorry, I don't know my left and my right. I'm really on this road, right? This is from the left of 0. So I'm on this road here. The limit as I approach the vertical line of 0, this is x equals 0. From the left side, I should be landing on the y value 1. Who doesn't see it? As we approach 0, which is really the y-axis, from the left side, we're landing on 1. In part B, I'm going in from the right side. So now this does bring us to this road here. And as I'm driving along from the right side, I'm hitting a y value of maybe -0.5. There would have to be reasonable answers here since it's not labeled exactly. So if you were like, oh, I don't know, I think it's more like -0.75, that's fine. As long as you're giving me something between 0 and 1. For argument's sake, I'm just going to say that we're approaching -0.5. Did you and your friend meet when you went to the diner or tried to go to the diner? There's a jump in the graph. This guy's up here. This guy's down here. The limit didn't exist. You did not meet. It's okay that that was an open dot. It's okay that from the right side, you're approaching an open dot. But it is not okay that there is a jump in the graph. So the limit as we approach 0 with no direction means from 2 sides, this one does not exist. And it asks us to explain why. So let's say because, and we'll abbreviate, left-hand limit does not equal right-hand limit. You could say because there's a jump or a break in the graph, but this is kind of a nice, concise way that's acceptable to say. Zoom out one more time so I could see the bottom part. All right, next one, we're approaching the the x value of 2 from the left and then from the right side. So I'm going to find 2. Oh, that's actually my vertical asymptote, x equals 2. So the first one here is from the left. So I'm going to have to look from the left side of 2 is this half of the graph or this section of the graph here. And the one closest to 2 is taking us down to -infinity. Now, the most descriptive way to answer this is by saying that you're going to -infinity. You're going to be following that asymptote down. You could never cross it. And you're heading down to -infinity. However, I did say that the solution to a limit is always a y value, and -infinity is not actually a value. It's a concept. So if you said it doesn't exist because it's going to -infinity, that's fine. It does not exist because it's going to -infinity. In other words, it's okay to say a limit doesn't exist if your answer is saying that's going to infinity. So then from the right side, it's heading to +infinity, or in other words, doesn't exist. I'd prefer to you answer with the infinity because it's more descriptive. All right?
Are we not using the linear, like
this part, right? Because what happens is this road dies before it gets close enough to 2. So you have to, since we're approaching 2, you have to get on the road that's closest to 2 so that you can follow it. So if you start tracing this part of the function here from the left and then it just is a dead end, you have to continue on the graph until you actually can get to the x value. Exactly. Other questions? So therefore, if the limit from the left side was -infinity, from the right side was +infinity, then when we jump up here to part F, the limit does not exist because the left-hand limit is not equal to the right-hand limit. Or you could say, because there's an asymptote there, really. So you could describe it any way that you want. If you wanted to say that it was because there was a vertical asymptote, I'm fine with that as well. The little negative sign that looks like an exponent means from the left. If there's just truly a negative sign, it will be in front of the number. So like this one's asking us -3, and then from the left side. So -3. Ooh, there's actually this weird dot there, right? A misplaced y value. But we're looking for not the y value. How do I know not the y value? Because I've got all this crazy notation in front of it. The limit as x approaches -3. It wants the intended height of the function, what you're approaching, and it's saying from the left side. So as I approach -3 from the left side, where does it look like I'm landing? 4. That's the limit. I don't care that it's a bullet hole in the graph. I don't care that it's defined someplace else. The limit is the intended height. Looks like I'm driving to that empty parking lot at 4. The limit as I approach -3 then from the right, again, what does it look like I'm approaching? The 4. So if from the left and from the right are both going to 4, then what's the limit that I approach -3? 4. And it does not matter that there is a hole in the graph there. But some of you might be sitting there like, well, what do you mean it doesn't matter? The hole in the graph means the y value doesn't exist. Why doesn't that matter anymore? Well, it only matters, it doesn't matter because of the limit. The y value doesn't exist there. And that matters if I ask, let's jump to part M. If I just ask you for the y value, f at -3, that's just asking you to evaluate the function. That goes back to algebra 1. There's no limit notation and all these arrows and whatnot. It's just saying, what's the y value? Well, the y value at -3 is actually not the open dot, it's the closed dot. The y value is 0, but that's not the limit. That's not the journey approaching -3, or in other words, the intended height. I feel like this is the most difficult concept with limits usually. Is there anything that's still unclear that I can try and explain a little better for you?
Why isn't the +3 coming? Why isn't that 1? Why is it 4?
All right. Take a second without me screaming and try the rest of these problems on your own as you're approaching -6. See if you can trace it on your own a minute. I think they can tell me the limit. Oh, let me zoom out once so I could see. There we go. The limit as x approaches -6 from the left. -6 from the left. Close. I think your answer I like for from the right. Because as I'm coming in from the right, it's 2. What's the problem with from the left? There's no road. How can I approach from the left when there's nothing there? This one does not exist. There's no road. So you're looking at the right point. That's why I said close, because it's not like you're nowhere near it. But if you can't approach it from that side, then it doesn't exist. Well, so if it doesn't exist from the left, can it exist at the point in part L? Can I say that the limit here exists if this side doesn't? No. So if it's an end point, then it can only be a one-sided limit because there's only one road coming in. N and O are asking for y values, not limits. So who could tell me f at 0? 1. F at 2? Yep, doesn't exist, or infinity. Questions? All right, I know there's some more to this lesson, but what I want to say is I want to kind of wrap up the lesson a minute. In your packets, just grab one of these. You have, what I skipped here was example 4 and 5, but then you've got an example 6 on the back. That's what I would like everyone to try on your own. And then the answers to it are at the bottom so that you could check right away to see if you're with it and you're understanding it. But skip the 4 and 5. We'll start the lesson tomorrow doing those before we move on. But this way you have an idea if you followed me in the beginning. All right, so those of you at home, you're going to do the same thing. Try number 6 on your own tonight. And then when I see you guys tomorrow,